work has been done means there must be some displacement. Without displacement, we cannot tell work has been done. What is scalar? It gives magnitude. It is independent of direction. If it is same unit vector, then it will be equal to 1. If it is different unit vectors, then it will be 0. Independent of the path taken in conservative force. In non-conservative force, work done by the force depends upon the path taken, and the force is called non-conservative force. Hello everyone, I am Nishma Nanjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to each one of you for my new session on Chapter 6, Work, Energy and Power. In this session, we shall study what do we mean by work and what are the different types of work and what is scalar product. We are familiar with the terms work, energy and power that we come across these three terminology in our everyday life. Suppose if I have to move the table from one room A to another room B. I am moving a table from room A to room B. I am applying some force to move the table from room number A to room number B. So, I'm doing work. So, this is the general definition how we describe work. So, how do we define work in terms of physics? So, scientific definition of work is different in many ways from our everyday life. So, let us describe this work, energy and power in terms of physics one by one. In today's session, let us study what is work in detail. Then we'll go through energy and then we'll go through power. So, what is work? Work is a scalar product. What is work? It is a scalar product of work. Is a scalar product of force and displacement given by S. So, work is a scalar product of force and displacement. Suppose I have a wall. Suppose I have a wall. A man is applying 5 Newton of force to push it. Suppose I have a wall in front of me. I am applying 5 Newton of force to push it. I am pushing it, the wall is not moving. The wall is not moving. I say the work done is 0. The work done is 0. Why? Because there is no displacement. Displacement is equal to 0. There is no displacement. I am pushing the wall, but the wall is not changing its position or it is not displaced. Hence, even though I am applying force, the work done will be 0. The work done will be 0. Say for example, I am walking. I go for a walk. That means I am applying force, my position is changing, I am not in the rest. From rest I am coming into motion. When I apply force, I am walking, I am changing my position. So my work done is not equal to 0 because I am changing my position. What do you mean by that? That means I am displaced from one point to another point, from one point to another point. So, displacement is not equal to 0, hence work has been done. In this example, you can see I am pushing the wall with 5 Newton of force, but still the wall is not displaced or wall is not changing its position. That means there is no displacement, hence work done is equal to 0. Even though you are applying force, work done is equal to 0. So, if work has to be done, then there must be some displacement. Remember, without any displacement, we cannot tell that work has taken place. Remember, without displacement, we cannot say that work has taken place. For example, consider, I have a ball, I have a surface, I have a ball A. It is at rest. Initially it is at rest. Now I apply some force to the ball. The ball will move towards the point B. The ball will move towards point B. So, the final velocity of the ball will be V after it is displaced with a displacement of S. It was at the initial position of the ball was at A. Initially it was at A at rest position. I applied some force. I am doing some work. I am applying some force. So, the ball is displaced from A to B and the ball will acquire velocity V when it is displaced the distance. Yes, so there is displacement. So, I say work done. I have done some work in order to displace the ball. So work done is not equal to 0 because there is displacement. Remember, displacement for work has been done means there must be some displacement. Without displacement, we cannot tell work has been done. So this is how we describe work physically in physics. So work is a scalar product of force and displacement. It is also written as W is equal to F cos theta. Yes, Fs cos theta. It is also written as Fs cos theta. So scalar means it's a dot product. It is also called dot product. So F dot S or Fs cos theta, where F is the force applied, S is the displacement of the object for the force that have been applied, cos is a function, theta is the angle between vector F and vector S. So this is work. Work is said to be done when a force is applied to an object that causes a displacement of an object from its position of rest or motion. Work is said to be done when a force is applied to an object causes the displacement of an object from its position of rest or motion. So SI unit for work, it is joule. It is measured in joule, or it is also measured as kg meter square second minus 2 kg meter square per second square. But commonly we don't use this as a SI unit. We use joule as a reference standard for measuring work. Reference standard for measuring work, it is joule given by J. So the work done by a force is defined to be the product of component of force in the direction of displacement and magnitude of this displacement. Work done by a force is defined to be the product of component of force in the direction of displacement and magnitude of this displacement, given by work is represented by capital W. W is equal to F dot S, scalar product of force and displacement. F dot S or Fs cos theta or Fs cos theta, where F is the force applied on the object, S is the displacement caused due to the application of force, cos is the function, theta is the angle between vector F and vector S. So when do you say 1 joule of work have been done? When will you say 1 joule of work have been done? When 1 Newton of force causes the displacement of object to 1 meter in 1 meter, theta is equal to 0, because when you apply force in this direction, the displacement will be in the same direction as that of force. So theta will be 0, cos 0 is nothing but 1, cos 0 is nothing but 1. If you substitute in this equation, of work, you will get 1 joule. The work done is equal to 1 joule. When will you say the work done is equal to 1 joule? When 1 Newton of force is applied to the object, that will cause the displacement of object of 1 meter displacement, and the direction of force applied will be in the direction of displacement. So theta will be 0, cos 0 is nothing but 1. If you substitute in this equation of work, you will get work done is equal to 1 joule. So dimension formula of work. What is work? It is work is equal to F into S. What is work? Work is equal to scalar product of F and S. F and S. So what is force? It is ml t to the power minus 2. What is S? Displacement is measured in terms of length L. So you will get m L square LL L2 t to the power minus 2. So this is the dimension formula of work. This is the dimension formula of work. It is a scalar product of F and S. F is given as mlt minus 2. L is the displacement is measured in terms of L. So it will be the dimension formula of work. We have studied about the dimension formula for work, velocity, acceleration in the second chapter. So please go through how we derive this dimension formula. So this is a dimension formula. In few textbook, instead of S for displacement, they have also used D to represent displacement. You can either use D or S to represent displacement. So this is about work. So we say work is a scalar product of force and displacement. So when we say the work has been done, if there is some displacement in the object, this is how we define work in terms of physics. This is how we define work in terms of physics. So next, you can solve a numerical, so that will help you to understand what is work much better. So a girl weighing 30 kg. So mass is given, it is 30 kg. Skips 0.3 meter height. That means displacement is given 0.3 meter. Height 20 times. So it is 20 times. Calculate work done by her. Calculate work done by her. So these are the given things. These are the given things. So I want to know what work. Work is F dot S. Work is F dot S. To calculate work done, I need force, I need displacement. I know what is displacement, but I don't know what is the force applied. So what I'll do, a girl weighing 30 kg skips 0.3 meter high 20 times. Calculate the work done by her. So a girl skips once. When a girl skips once, she's standing on the floor. When the girl skips once, herself, she's lifting her vertically up by the height 0.3 meter. She's skipping. When she skips once, she lifts herself for a vertical height 0.3 meter. Then under the influence of gravity. So I can write force is equal to mg. Force is equal to mg. What is mass? It is 30. What is the gravity value? Gravitational value, that is 9.8. So what is the value that you get if you multiply 30 into 9.8? It is 294 Newton. Force is measured in terms of Newton. Now I got the force. Now what is the work done in skipping once? She is skipping 20 times. Height 0.3 meter. So what is the work done in skipping for once? It is force 294 into, it is 294 into 0.3. So what is the value that you get when you multiply? It will be 88.2 joule. Work is measured, SI unit for work done, it is joule, represented by J. Now work done in skipping once. She has skipped 20 times. So what is the work done in skipping for 20 times? So work done for 20 times is equal to, work done for 20 times is equal to, for once it is 88.2 into 20, it will give you 1764 joule. So this is the work done by her skipping for 20 times of height 0.3 meter. So what is given? Mass is given 30 kg. Displacement is given. It is 0.3 meter. She is skipping for 20 minutes. To calculate work done, I want force. So to calculate force, each time when she skips, she is lifting herself vertically upward in the influence of gravity. So I'll calculate F is equal to mg. F is equal to mg. M I know it is 30. Gravity value is 9.8. I get 294 Newton as the value of force. Once I know force, work done is what? Work done in skipping for once. 20 times she has skipped. I need to know work done for skipping once. So once it is 294 into 0.3 will give you 88.2 joule. Once you know what is the work done in skipping for once, then you can calculate for 20 times. So 88.2 multiplied by 20 will give you the total work done by her for skipping 20 times. This is how you calculate work done. So next you have another numerical where you have to calculate the angle between the force applied and the displacement produced. The angle between, if you have force And if you have displacement vector, what is the angle between the force applied and the displacement produced? What is that angle? You have to find out. So a force of 50 Newton is acting on a body, produces a displacement of 2 meter, produces a displacement of 2 meter. If work done is 75 joule, find the angle. They are asking cos theta. Find the angle between the force applied and the displacement produced. We know work done formula is Fs cos theta. Fs cos theta. So I want to know what is the cos theta here. So what I'll do? It is cos theta is equal to W by F. Yes, W by F. Yes. So I want to know what is angle. Everything is given in the question. I know force, I know displacement, I know work done. Substitute 75 divided by 50 into 2. Displacement is 2. So you'll get the value cos theta is equal to 0.750. Theta is equal to, take the cos to LRHS, it is cos inverse of 0.750. So using logarithmic table, you will have the column for natural cosines, natural sines. Under natural cosines, if you find the value of 0.750 using logarithmic table, you will get theta is equal to 41 degree 24 minute. 41 degree, this is representation of degree, dash represent, it is in minutes. So 41 degree 24 minutes. This is the theta. This is the angle between force and displacement. So force is given, displacement is given, W work done is given. So I need to know what is the angle theta. So this is the formula for work done. So on simplification, I'll get theta is equal to 41 degree 24 minutes using logarithmic table. I simplified the theta value. So next we are telling that work is a scalar product of force and displacement. So we'll understand what do you mean by scalar product, which we have discussed many times in our previous sessions. So what is scalar? It gives magnitude. It is independent of direction. It is independent of direction. So what do you mean by scalar product? It is also called as dot product. Instead of this symbol, we are using dot. So scalar product is also called as the dot product. So it is a process of multiplying two vectors. It's a process of multiplying two vectors. Multiplying two vectors will give you scalar. So scalar product of two non-zero vectors A and B. Consider I have two vectors A and B. Consider I have two non-zero vectors A and B. It's defined as a product of magnitude of vectors and cosine of angle between them. So if I want the scalar product of these two vectors, that is A dot B is equal to magnitude of two vectors and cosine of angle between them, So we use cos theta in scalar in finding dot product. So if you have two vectors A and B, if I want to find out what is the dot product, that is a scalar product of the two vectors, then it is A dot B is equal to magnitude of two vectors and cosine of angle between them. So you can see A dot B is equal to magnitude of two vectors and cosine of angle between them. So these two vectors cannot be equal to 0. Because the terms inside this modulus, this is the mod symbol. So the terms within this modulus symbol has a definite value. The magnitude has a definite value. So that cannot be these two terms. The terms inside this mod cannot be equal to 0. So dot product of two vectors is equal to magnitude of two vectors. Suppose we have P and Q as two vectors. This is vectors. The dot product of two vectors is P dot Q is equal to magnitude of two vectors and cosine of angle between them. Cosine of angle between them. So there are two methods of multiplying the vector. One is dot product and one is cross product. Dot product is nothing but scalar product. Dot product is nothing but scalar product, and cross product is nothing but vector product. Cross product is nothing but vector product. In this session, we'll only concentrate on dot product. Cross product is nothing but, it is a vector quantity, finding out a vector product. So in terms of cross product, if you have two vectors A and B, then it will be A magnitude of A vector, magnitude of B vector, and it will be sine of angle between them. We use sine theta here. It will be sine of angle between them when we talk about cross product. So in case of dot product, it magnitude of two vectors and cosine of angle between them. Dot product is also called as scalar product. So next, consider I have two vectors A and I have vector B. Cosine of angle between vector A and vector B, that is theta. Now what is the projection of B on A? I want to find what is A dot B. Now what is the projection of B on vector A? So that will be AB cos theta. So this will be B cos theta here. The projection of B on A. In case I have two vectors B, so drop the perpendicular on the vector A. Suppose I have two vectors A and vector B. Angle between vector A and vector B is theta. Now what is the projection of A? I want to find what is vector B dot vector A now. I want to find what is A dot B. So it is the projection of B on A. So I want to find what is B dot A now. It is the projection of A on B. It is the projection of A on vector B that I am drawing a perpendicular. That means it is A cos theta here. It is B A cos theta. So you can see I want to find A dot B. That means the projection of B on A. It is the projection of B on A. I am dropping a perpendicular to vector A, that is 90 degree. So projection of A dot B will be AB cos theta. Similarly, I want to find B dot A. That means it is the projection of A on B. So I am dropping a perpendicular from A to B. That will be A cos theta. It is BA cos theta. So it is the same, but here it is the projection of B on A. Here it is the projection of A on B. So we know work is the scalar product of, force and displacement. We know force is a vector quantity. We know displacement is a vector quantity, right? But what is work? Work is a scalar. What is work? Work is a scalar. Look at how beautiful it is. Multiplying two vector quantities, force and displacement, is giving you a scalar quantity, that is work. Multiplying two vector quantity is giving you a scalar quantity, that is work. So similarly, this is about dot product. Similar to dot product, we have cross product, which I have already told you, cross product. In cross product, we want two vectors A and B. So it will be magnitude of A, magnitude of B, sine of angle between them. It is not cos, it is sine of angle between them. So your A dot B will be equal to magnitude of A, magnitude of B, sine of angle between them. So it is sine of angle between them. And in case of cross product, the resultant we get, here it is scalar, here the resultant, by taking cross product, we will get the resultant as a vector quantity. We will get it as a vector quantity. Vector quantity is also called as cross product. So, where we are concentrating more on the dot product. Instead of multiplication, we are using a dot to represent scalar product, represent scalar product. So there are few conditions. There are some conditions for dot product in case of unit vectors. So what are those conditions? That the first one is commutative law, which we have discussed in the previous sessions. First is the commutative law, that is A dot B is equal to B dot A. A dot B is equal to B dot A. So if there is change in the order of A or B, the result will not change. It will be same. If there is change in the order of terms, the resultant will not change. The resultant will also be same. For example, 2 into 3, it is 2 3s are 6. 3 into 2, it is also 6. If there is change in the order, of A or B, the resultant will also remain same. The order of the resultant will not change. So that is commutative law. A dot B will give you B dot A. Similarly, the second condition is distributive law. Distributive law. What is distributive law? A dot B plus C is equal to A dot B, A dot C. A dot B plus C is equal to A dot B, A dot C. This is distributive law. Scalar product or dot product for a unit vectors. For unit vectors, we know if there is 3 axes, that is x, y, z. There are 3 axes. This is a 3D space. When you have 3 axes, the unit vector, what does unit vector give? Its magnitude is unity, but it specifies direction. It specifies direction. So its direction of the object along x is given as I cap, represented by cap over its head. So along y it is j cap, along z axis it is k cap. So in terms of unit vector, dot product in case of unit vector, the dot product in case of unit vectors are given as follows. So if it is I cap dot I cap, then it is equal to 1. The value is 1. If it is j cap dot j cap, it is 1. If it is k cap dot k cap, it is equal to 1. Dot product of unit vector, that is equal to 1. If it is I cap dot j cap, two different unit vectors, the scalar product of two different unit vectors will be equal to 0. If it is same unit vector, then it will be equal to 1. If it is different unit vectors, then it will be 0. If it is j cap k cap, then it is equal to 0. If it is j dot j, it is 1. If it is two different unit vectors, it will give you 0, value 0. This is the scalar or dot product in case of unit vectors. In case of unit vectors have magnitude unity, but will specify the direction of the given object in the 3D space. Now to understand this scalar product for a unit vector, we'll solve a numerical. Where the force is given. This is the force acting on a body or an object that will produce a displacement. When we say a force is acting on a body, there is a displacement. That means work has been done. Now I have to calculate what is that work done by the force. So the displacement is given as S is equal to 6 I cap plus 5 K cap. Now I want to find what is work done by the force. How will you calculate work done? Work done is equal to F dot S. F dot force dot S, scalar product of force and displacement. So if we want to know what is work done, I have already the value of force given. It is 5 I cap plus 6 j cap minus 4 k cap. Dot product. Dot, what is displacement? It is 6 I cap plus 5 k cap. So I want to find what is work done. I have force, I have displacement. So what is the scalar or dot product in terms of unit vectors? So I have 5.6. That means 5 6 it is 30. What is I cap into I cap? I have said it is equal to 1. So I cap into I cap dot I cap is 1. So 30 I have 6j, but I don't have j, unit vector j in case of displacement, so it will be equal to 0. So I have j in the force, but I have no unit vector j in case of displacement, so that will be equal to 0. So what is minus plus? It is minus. Minus plus is minus. What is 4 5s are? 4 5s are is 20. Again k dot k, it is 1. If it is k dot I, then it is equal to 0. It is k dot k, same unit vector, so it is equal to 1. So 20 ones are is 20 itself. So it is 30 minus 20 will give me 10 units. It will give me 10 units. So this is the work done by the force that have been applied on the body that is causing displacement. This is how we calculate work done when we have scalar product or dot product in terms of unit vectors. F is given, S is given, work done formula directly I am applying it. So for 5i, I have 6i in displacement. I have 6j in force, but I don't have j term in displacement, so it is 0. I have 4k, I have 5k in displacement. So on simplification, you will get it as 10 units. So I hope the scalar product in case of unit vectors are clear. If it is same unit vector, it is 1. If it is different unit vector, dot product of different unit vector, it is 0. So these are the conditions for dot product in case of unit vector. It should be commutative, it should be distributive. So next we have conservative and non-conservative force. In force we have two types, that is conservative and non-conservative force. What do you mean by conservative force? Conserved. So conservative force means the work done by the force, you are applying the force, the displacement has been caused, that means there is a work done by the force that you have applied. So work done by the force does not depend on the path taken, does not depend on the path taken, and it depends only on the initial and final state of the body. The force is called conservative force. For example, I have an object A. I am standing in the position A. Consider I am standing in position A. From position A, a force is applied on me. I will move towards position B. I may move in straight line, or I might follow a zigzag path, or I might follow a curved path to move towards point B. So this is my initial state. I was standing at point A. Some applied force has been applied on me. I will move towards point B. This is my final state. I might move in the straight line. I might follow the zigzag path. I may follow the curved path. So the path taken does not matter. The path taken does not matter. Work done by the force does not depend on the path that I have taken, but it just only depends on the initial state and my final state of the body. So that is called conservative force. So example for conservative force, it is gravitational force, spring force, etc. So gravitational force is conserved. Consider the example of freely falling object or a body. Consider the example of freely falling object or a body. When the ball is dropped from certain height towards the ground, there is an influence of Earth's gravity. When the ball is dropped, it will move straight towards the Earth. So if there is no any air resistance, it will move straight. It will not follow any path. It will move straight from the rest state to the final state, that is ground. So the gravitational force, what is pulling the ball down? It is the Earth's gravity. So gravitational force is conserved. Similarly, spring force are the example for conservative force. Then what is non-conservative force? What is non-conservative force? If the work done by the force, depends upon path taken, if the work done by the force depends on the path taken, here it is independent of the path taken in conservative force. In non-conservative force, work done by the force depends upon the path taken, and the force is called non-conservative force. If I am position A, some force has been applied on me, I will move towards position B. So, initial and final state is not mattered here. Initial and final state, it does not depend on initial and final state. It depends on the path taken by me to move from A to point B. So, it depends on the path taken. So, that force is called non-conservative force. Example as friction force, viscous force, air resistance, etc. Some of the example for conservative force. If I ask the difference, between the two forces, that is conservative force, and if I ask the difference between non-conservative force. So what is the difference? If I ask for the difference, what are the difference? First point is the definition of the force itself. So non-conservative force, the work done by the force depends upon the path taken. The force is called non-conservative force. First is the definition. You can tell the definition as a first difference. Work done by the force does not depend on the path taken. So the second point is non-conservative, it depends on path taken. Whereas conservative force, it does not depend on path taken. So what is the example for conservative force? It can be spring force, gravitation force, etc. What is the example for non-conservative force? It can be frictional force, viscous force, etc. or air resistance, etc. And here in non-conservative force and conservative force, in conservative force, it is central in nature. Whereas non-conservative force, it is retarding in nature. This is retarding in nature and it is central in nature. And here you can see in conservative force, the work done is recoverable. It is recoverable. In non-conservative force, the work done is not recoverable and it is retarding in nature. This is central in nature. So you'll get the question, what is conservative force and what is non-conservative force? Give the example and differentiate between non-conservative force and conservative force. First, you can write the definitions of non-conservative force, conservative force with respective examples. And here, it depends on the path taken. Here, it is independent of the path taken. And the work done is recoverable here and it is not recoverable here. And it is central in nature and it is retarding in nature. These are the few differences that you can mention. That's all for today's session. In today's session, we studied what is work in physics. In terms of physics, we define work as a scalar product of force and displacement. So, SI unit of work is joule and we saw the dimension formula for work. Then we studied the scalar product. What do you mean by scalar product? It's also called as dot product. How do you find out the dot product of two vectors? It is magnitude of two vectors into cosine of angle between them. After work, whenever we say work has been done, there must be displacement. If there is no displacement, then there is no work have been taken place. Then we studied about conservative and non-conservative forces with examples and we solved few numericals to understand scalar product in terms of unit vectors and to how to obtain the value for work done using the formula Fs cos theta. So in next session of work, energy and power, I'll come up with more interesting topics and derivations. Until then, take care. Have a good day. Thank you.